in business. So, good morning, good afternoon, or good evening, depending on where you are based. Friends, welcome to the webinar on migrating self-managed Elasticsearch into our managed offering Amazon OpenSearch service. My name is Baral Shah. I'm a principal go-to-market analytics team member here in the Northeast, and we have a line of speakers not only from AWS, but also we have invited our customer as well as partners whom you will be hearing in the later part of the presentation. We have a packed agenda for close to 50, 60 minutes. So let me give you a quick rundown. I will kick it off with giving you a high level overview about Amazon OpenSearch service, what are its capabilities, what are its features, how customers are using it. Then I'll hand over the baton to our customer, LabCorp. They'll be sharing their migration story, specifically about the challenges they were facing and how they resolve those challenges using the managed offering. Further, you will hear from Kevin Fallis, who is a principal specialist solution architect with AWS, who has been working for the last couple of years, helping customers globally in this journey. He will first touch upon the planning process, and then he will dive deep into various tools and techniques. And the last part of the presentation, you will hear from our AWS partner, Kaizen Analytics, who will be talking about one of the customer financial institution customer, how they help them to resolve that challenge. And then when the time permits, we'll open up the floor for question and answers. But my guidance is, friends, if you have any questions, please feel free to use a chime chat. And what we have done is we have a couple of solution architects who specializes in OpenSearch would be happy to answer any questions as and when they come up. And the last bit of information is please ensure you fill up the survey, because once you fill up the survey, then only we'll be able to send you the deck as well as the recording for your reference. So that's the logistic aspect. Let's dive deep into OpenSearch service. Now, Amazon OpenSearch service is a managed offering from AWS where it basically makes it super easy for our customers to deploy, operate, and manage and scale OpenSearch. And also for the backward compatibility, we support prior 19 versions of Elasticsearch on AWS platform. So if you really think it through, OpenSearch is a community-driven, open source search and analytics platform, which is forked from Apache 2.0 licensed Elasticsearch and Kibana 7.2, 10.2 version to be precise. We have a lot of partnership from various organizations, companies like SAP, even Goldman Sachs, Oracle have contributed actively to this community-driven framework. Matter of fact, Oracle has embraced this OpenSearch platform on their Oracle Cloud platform too. Now, if you think it through, OpenSearch has three key components. So one at the heart, of course, is the search engine, what we call as OpenSearch. It also has this rich user interface to create your reports, what we call as OpenSearch dashboards. Now, if you are familiar with the Kibana or the Elasticsearch, this is pretty much similar to Kibana. And the last component has various tools and plugins for various functionality. So for example, let's say you want to do find and access control. We have a tool and plugin for that. If you want to use anomaly detection like machine learning capability, we have plugin for that. And by the way, all those capabilities are offered to you out of the box without any configuration. So when customers decide to embark on this OpenSearch journey, they get some benefits right off the bat. First and foremost is we make it very easy for our customers to deploy a production grade OpenSearch cluster, whether you are using a console, a AWS console, where it literally within few clicks, you can have your cluster up and running in a matter of minutes. Or alternatively, if you want to deploy as infrastructure as code, you can use tools like CloudFormation templates or Terraform and then make it operational. The key thing is it also simplifies a lot of management tasks for you. For example, backup, patching, provisioning, upgrades, even maintenance and monitoring, all those things AWS will take care for you. So the advantage you as a customer get is you are freeing up the time of your engineers or your developers so they can focus on something which is more meaningful, more impactful for your organization. The other thing is it's highly secure. Like security is job zero at AWS. And particularly for this service, we provide you capability to encrypt the data in transit as well as at rest. Sometimes you want to also have find and access control. For example, security conscious customers, healthcare customers, financial customers wants to control who can access the indices or the indexes within OpenSearch, you can do that. Or even you can be as granular as a field level, and you can do that using these open source plugins. Also, it is cost effective. Under the hood, it uses our compute capacity EC2 instances. So by virtue of your reserved instances or savings plan, you can reduce the cost for your OpenSearch. Also, we do support Graviton instances. Now, if you're new to this, Graviton instances are developed in-house by AWS using its own Nitro chipset. And if you use Graviton chipset instead of x86, it helps you to increase your price and performance by almost 30-40%. And finally, it is highly scalable and available. Like if you have to scale your cluster either horizontally or vertically, you can do literally with a click of a command in OpenSearch. If you are familiar, if you are from the DevOps world, you will be familiar with the term called blue-green deployment. We use the same principle when we have to scale your cluster in OpenSearch. And also, we recommend you to use the capability of multiple AZs or availability zones within our AWS platform to eliminate single point of failure. So those are some key advantages customers get by using OpenSearch. So all in all, if you compare self-managed versus a managed offering from OpenSearch, as you can see on the screen, we give you a lot of capabilities. For example, we will take care of your hardware and operating system maintenance and refresh. We also do automated backups. To reference, we take incremental backup every hour, and we hold it for rotating last 40 days at no extra cost. We do take care of the upgrades and patches. You decide when you want to do it, and OpenSearch will do seamlessly behind the scene for you. The other thing I want to draw your attention is particularly for the log analytics use case. It has some neat features like ultra warm storage or cold storage. So for example, let's say you have to hold your data for a longer retention period, maybe because of financial reasons, because of compliance, or whatever the case may be, but you don't want to shell that much money to hold that long-term data. Using features like ultra warm and cold, you can keep your data for a longer period of time in a seamless manner. Again, I don't know we have time today, but you can migrate your data from hot to your ultra warm tier, and then you can hold the data almost at 70 to 90% cheaper within OpenSearch. And that's the reason why you see customers across various verticals, various use cases. Some of the names you might be already familiar with it, but customers like Pinterest, like even customers like Capital One Bank are using to meet their business needs, maybe in case of log analytics, in case of traditional search, or sometimes for forensic analysis too, they use OpenSearch capabilities. And when there is a trend going on where customers are migrating from self-managing to this managed offering, and there are three key reasons. The first and foremost is, I don't know how many of you already have Elasticsearch in-house, but if you have that situation, you know you need a dedicated team to maintain your Elasticsearch cluster. But not only that, you want to ensure that it is performant. But now compared to the managed offering AWS provides, it makes it very easy for you to reduce your TCO or total cost of ownership. The other challenge it addresses is if you have, let's say, Elasticsearch, and if you want to use some advanced features like security, alerting, or monitoring, you might have to shell some extra money. But in OpenSearch framework, we give you out of the box without any extra charge, and you can start leveraging as soon as your data is ingested into OpenSearch. And the final advantage is if you're managing yourself, of course, you need to have your infrastructure, and also you need to schedule your refresh or upgrades at a regular cadence. But in case of OpenSearch, we'll take care of that automatically. So there are some inherent advantages, and that's the reason why customers are moving into this managed offering. And speaking of that, now I would hand over the baton to the LabCorp team. Let's hear firsthand from them what are the challenges they were facing and how they resolve it. So I'll hand it over to Tamil from the LabCorp team. Please take it away, sir.
All right, thank you, Viral. Can you hear me okay?
Yes, we can.
Yeah, hi. Hello, everyone. My name is Tamil Ramasamy. I work as an IT director at LabCorp. With me, I have Ashwin Dora, who's a senior software engineer. Ashwin and myself were part of a call center migration effort in LabCorp to modernize our existing call center system. And we also used Elasticsearch for some of the critical data that we stored on our backend. So next slide. Yeah, so let's look at the business use case, and then we will go through some business challenges or operational challenges, and the reason for us to move to, or the benefits for us to move to the after we move to OpenSearch. From a business use case, so since it's a lab part, we store close to 12 years of patient results in the index, in the cluster, and apart from the results, we also store the customer master data and also the clinical test catalog of LabCorp. So all of this amounts to close to 2 billion records and 5 terabyte of storage. This is a time series data because it's patient results every day, every minute, as our LabCorp lab systems gets resulted, we get the notification of the results, and we get close to 25 to 30 million records per month. Like as I mentioned, the whole cluster of the access to the data is being used in call center operations. So when our agent gets called from physician office or patients to have any questions related to their results, and this system is used to answer these questions. So we get close to 100 search requests per second, and on a daily basis we get close to 500,000 to 1 million new records getting ingested to the cluster. So this cluster using Elasticsearch was built in like 2019, close to end of 2019. We built it, it was all went to production, everything is great, everything worked great. But when we look back from an operational challenge, those are the things I want to go with you, where though it was built as a cluster, most of the work was done using manual cluster setup. So including the EC2 instances or any AWS resources like ALB or security group was set up using manual processes. And, because of this manual effort involved, we didn't want.
Isso aqui tá super corrido.
There was can someone go on mute, please? Okay, so because this is an all manual effort, so any changes to the cluster is also going to be taking some an effort to involve. So that leads to an oversized cluster. So we didn't want to leave any risk on the table because on overutilized cluster. So our EC2 nodes tend to be on the higher side of the resource. And also the homegrown, so we had to build a homegrown solution for monitoring. So there is not something, we used a Kibana when we needed, but most of the cluster level main monitoring was we had to rely on some of the application monitoring tools that we used in-house. And this is one of the bigger concern from ours is only fewer team members had the expert knowledge of the cluster, like from the initial setup and how the whole thing work and replication or sharding, balancing of the index, and all of that was like only fewer team members were aware of this, and it was a steep learning curve for the rest of the team to understand the cluster maintenance operations and troubleshooting. Also, the upgrade to the newer version, it's again a manual effort. So when we prioritize with our business features, it always took the backseat, considering other business features that had a higher priority. And the last but not least, licensing cost. It's not really an operational challenge. It was one of our criteria when we looked at OpenSearch as a solution for this. Okay, next slide.
Sorry about that.
No problem. I thought I probably lost my audio. Okay, thank you. So all those challenges, then we considered going to OpenSearch service, a managed cluster. And so from the day one, we planned to address all these concerns. And so when we built the new cluster, we used a Terraform to create and scale. So any changes that needed for the cluster now, we will be able to deploy using Terraform, using our regular DevOps pipeline like we do for any application infrastructure. That also gave us the confidence to have a right-sized cluster, and along with AWS tech support from this journey from the day one. Technical support from AWS helped us to plan for based on the existing traffic and the ingestion load. And the monitoring and dashboards was all provided part of the AWS OpenSearch service. So now we also built some custom dashboards, in CloudWatch. Which is being used for our regular monitoring and troubleshooting. I mean, we're all mentioning there is automatic backups are all being taken care of by the service itself. So overall, it provides a lower, or it helps to lower your labor cost of maintenance. So our application team now don't need to worry about, backups, or don't need to worry about how to add a new cluster, new node to the cluster, or upgrade, for example. That's been now taken care of by the service itself. So there is no licensing cost for this. And last but not least, IAM security. So when we used Elasticsearch cluster, we used a basic authorization as an authentication. With OpenSearch, AWS OpenSearch, now that's provided by IAM security. So you could have a policy based on a domain, or you could have a policy, even fine-grained control of to access control for a given field within an index or a document. So those are the benefits of after we move to OpenSearch. So when we come to the long-term plan, so because of this ease of use and implementation, we believe the OpenSearch would be used in other business use cases within the organization. So the adoption of the technology is going to be easier. So more and more application team would be looking to utilize the Terraform scripts, or even to learn from us and use it for other business use cases. And as I mentioned, it's a time series data that we store, and our storage is growing every day and every month. So we are looking to utilize ultra warm storage for some of the historical data, as most of our call volumes tend to be for the recent years, last 2-3 years of patient results. So there's going to be a significant reduction in storage cost by moving some of the historical data to ultra warm. With all the manual work has been taken care of, we believe the OpenSearch migration, you also get the peace of mind that you don't have to worry about a cluster going down middle of the night and getting a call from the operation team middle of the night. So I personally feel that's a huge win for my team. I know that's another benefits of moving to AWS OpenSearch. That's all I have to share this morning. Thank you, everyone. We will stick around for any questions at the end. And thank you, everyone. We're all back.
Thank you, Tamal. Kevin, I'll hand over the baton to you, Kevin.
All right. So thanks, everybody. Again, my name is Kevin Fallis, Principal Specialist Solutions Architect, and I work with customers all day long on migrations and using the OpenSearch service. So let's go ahead and forward quick here. I want to make sure I cover all the topics here in the time allotted. But when we look at migrations, there are multiple steps involved. And so, Viral, go ahead and just hit the build out on this. First of all, you're going to qualify and plan. After you do a qualifying and planning, and what's involved in qualifying and planning is understanding, what your version requirements are, what the functionality is that you'll need, along with a bunch of other things such as training your team and whatnot to understand how to use this service and implement it with your solution stack. But once we've gone through the qualification and planning, which involves sizing and understanding costs and functionality, then we move into technically what we present as a POC. Now, what we'll do is work with you on a POC to ensure that it fits your requirements, and it then is able to socialize that functionality to the stakeholders at your company, such as your C-suite executives and people that want to understand how the solution is going to work. Once you've done that and you've established the functionality and meet your requirements, we go into a deploy phase. Now, a deploy phase is where we actually push the solutions into a staging environment, or which will most likely become your production environment. And then we work through the final things such as runbooks, connectivity, security to make sure that you address all the needs for security, privacy, compliance as directed by your company. Once we've established the environment is set to our expectations, then we work on bringing the data in from your existing solution to the new solution. In this case, say you're migrating from a self-managed Elasticsearch, into the Amazon OpenSearch service. If your versions happen to be compatible with the solution itself, we can use snapshot restore. But there's also a couple of other mechanisms that we'll talk about here in the following slide deck that brings this data in. But once you brought the data in, technically we want to keep those solutions in sync for the time that we're finally going to swap and present our new cluster to our customers. So in this case, these are the 6 steps that we typically walk through people with. And Viral, go ahead and pop to the next slide. So as I mentioned, when you're in the migration planning, you want to look at functionality, version dependencies, operations, and security. So for example, as was mentioned by the LabCorp team, being able to use fine-grained access control or security mechanisms. These are things that you want to evaluate. Also, your deployment frameworks. For those of you that use Terraform or CloudFormation or CDK, you want to make sure that your current implementations can then be modified to use the Amazon OpenSearch service. From a training perspective, I talked about this a little bit earlier, but you want to make sure that people understand, how do I organize my run books? How do I understand if I have to do re-indexing or other activities? How does that work? Which is very similar to how you do it in Elasticsearch, but how would that work for my team? You also focus on data ingestion, making sure your ingest pipelines in most cases can be seamlessly just repointed using our OpenSearch, say Logstash plugin if you use Logstash. But the final thing is you also want to make sure that when you plan, you meet your KPIs and the business continuity, which means when we cut over from a Elasticsearch self-managed or an OpenSearch self-managed to the managed offering, you want to make sure it's as seamless as possible so that your downstream customers have a nice experience with the transition. Next one, for all. Again, so we'll talk about migration tooling. Go ahead and one more, Burl. So there are a couple different ways that I look at things. And when we look at the tooling that's involved, there are different approaches that you can leverage. You can build from source. You can build from a snapshot, which we're going to talk about right now. You can actually use tools to copy from one cluster to another, and we'll discuss those here a little bit deeper. But when we look at migration efforts, I usually go for something that is simple. And if we look at the Amazon OpenSearch service and we look at what OpenSearch is and the Elasticsearch engine that it runs, in most cases, you can bring snapshots of your older versions and even your newer versions into the Amazon OpenSearch service as long as you're at 7.10.2. Now, the snapshot approach is really an easy way to bring data into the service. You basically create a snapshot repository. You store this on S3. The Amazon OpenSearch service has a direct integration to read those snapshots from S3. And typically, you're able to then bring that snapshot into the service, and your data will all be there. Now, keep in mind that newer versions can read the last major version of a snapshot. So a version 7 could technically read a version 6, and the minor versions within there. But what you can't have is, say, a version 7.16 trying to restore them to a 7.10. And so, when we talk about looking at the migration planning and we talk about how I understand the tooling, the snapshot is a valuable piece of that. But in some cases, snapshots don't fit the requirements based on newer versions. So we'll talk about this here in a second. But Viral, go ahead and page through. So, one of the things that we do also have to consider here is that the Amazon OpenSearch service does rely on IAM. So make sure that your S3 buckets do have the appropriate permissions. And usually, if you do restore from an older version, technically I like to reindex to make sure that my Lucene versions are all on the same page and I get the best performance I can based on the solution I'm getting myself into. But next one, Pearl. So when we look at the tooling considerations from building from source, which is our next offering, so we just talked about the snapshot, but we want to talk about source. Now, source can be multitudes of things. You could already have, say, file beats that are emitting logs. You have agent-based collectors that are emitting logs from the different things such as FluentBit or FluentD. But when we look at things and building from source, there are certain levels of effort. So Viral, go ahead and page for the high. So when we talk about a high level effort, you're doing custom code. You're going to build it, you're going to deploy it, you're going to manage it. Technically the support is your engineering team. Now, when we look at a level of effort that's medium, it's going to involve some tooling. So I'll just go ahead and hit the build out. All right. And so when we look at a medium level of effort, we look at connector-based tools, such as things like Logstash, things like a remote reindex, and other offerings that are either open source or come from our partners in our partner ecosystem, or even through ISVs and other vendors that have tooling that they've built. And finally, we look at other levels of effort such as low, such as purpose-built tools. Now, in this case, you might have a marketplace product that you pull and you install, and it points from your existing cluster and can write to your new cluster. In this case, the level of effort is just writing data movement scripts and configuring the security around that to get access to the data in cluster A to write to cluster B. But let's move on to the details here around that tooling. So technically, when you build from source and you use custom code, keep in mind, you're going to have developers. You're going to have engineers that can understand how to write the code to do the work that you want. Now, normally you don't find custom code being a heavily leaned on activity unless you have some unique ways that you're using your specific search clusters right now. And it's highly possible if you're using a different version or some other search solution, you will have to use custom code. But Bral, go ahead and page this out down to the bottom. So again, it does require a development effort. The effort is typically throwaway because you do it once and done. You're going from version A to version B, but in the end, once you've migrated all those clusters, you're not really going to have the need for that code anymore because as time goes by, you're getting into newer versions. But typically, you'll deploy this stuff on Amazon EC2, containers, or AWS Lambda. Next slide, Bro. And just go ahead and hit the build out hit it 4 times. There you go. So when we look at building from source and connector-based tools, there's a bunch of things that are out there in the ecosystem. If you happen to have workloads that are on EMR, you can use the ES Hadoop connector. If you happen to use Logstash, we can use Logstash to have an input from, let's say, your old Elasticsearch cluster and output to the new Elasticsearch or OpenSearch cluster, depending on what you implement on the Amazon OpenSearch service. On top of that, agent-based architectures such as FluentD, FluentBit, all have the ability just to update a configuration to point to your new cluster. So technically, if you're doing a log analytics solution, you can just repoint your ingestion pipelines to the Amazon OpenSearch service using the correct output plugins. So again, these are typically deployed on Amazon EC2, containers, AWS Lambda, or in the Hadoop ecosystem using the AWS or using the ES Hadoop connector. Next one, Val. So the final part is using existing ETL tools. So in this case, there are many products that you can find in the partner ecosystem from vendors, ISVs, at AWS that have built these toolings. If we look at it across the board, what there typically be is a managed service, like, say, the AWS Database Migration Service, which enables you to read, say, data from S3 and move it into the Amazon OpenSearch service, or read data from a relational data store and move it into the Amazon OpenSearch service. And again, it's just a configuration. You have out-of-the-box integration with those multiple sources. Your time is going to be spent creating those high-level data movement scripts, maybe the queries, maybe some tables to move across to the Amazon OpenSearch service. But in the end, you can look at ETL tools, and these can simplify your migration efforts. All right, Val, next one. All right, so the final one we would look at is building from existing self-managed engine. Now, if we look at the Amazon OpenSearch service and the capabilities that are out there, we released a feature called Remote Reindex. Now, Remote Reindex does read from a source and write to a destination cluster. The Remote Reindex can read from an externally managed offering or self-managed offering, and you effectively configure that to then write or read from that cluster and write to the Amazon OpenSearch service. Now, there are other offerings out there that you could use also. You can, from build from a self-managed engine, such as I mentioned, Logstash, you can install this stuff on EC2 or containers, and then the inputs and the outputs enable you to take that data from where it sits in your current offering and write it to the Amazon OpenSearch service. Now, keep in mind that you do have to pay attention to your security settings. And when you look at AWS, and if you're doing some on-premise migrations, you may have to consider some complex networking or authorization frameworks, depending on how your company is orchestrated around security and compliance. All right, Burrell, next slide. So this brings us to the next approach that you have. Now, I talked through the tools that you could do, that you could use to do migrations yourself. But many customers find that partners are a way to accelerate their adoption. It's possible that you or your engineering team don't have the resources to perform a migration, but you really want to. So AWS looks at the partner ecosystem as a way to help customers such as yourself bring a level of expertise to your company for the duration of a migration to enable you to be successful. So I want to introduce Kaizen Analytics. They're going to talk to you here for the rest of the session about how they treat migrations, and they'll discuss, what their process is and what their approach is. And from there, you should have a holistic view of the tooling and the partners that you can leverage to help a migration to the Amazon OpenSearch service. Kaizen team, take it away.
Thank you, Viral and the team. So this is Sujit Singh. I'm Director of Technology with Kaizen, and I have my colleague Kishore, who's an enterprise architect. So we'll be taking you through some of our case studies. Before that, I wanted to take time to introduce what Kaizen is. As you see, we work with multiple clients in the North America area. We are helping clients in all the maturity phases of analytics, as from foundational to prescriptive. We have been working to build the analytics and also help them on any custom application development needs. We specialized in the log analytics area, and we have subject matter experts that can help in the area of migration. I'm just going to give the forum to Kishore to take you through the use case that we worked with this financial institute. Now, just to kickstart that, this was a large financial company that had a very strict requirement of making sure the migration is done the right way and they are complying to their compliance need. Kishore, you want to take them through the journey what we went through, and then I can hop in as and when required.
Yep. Thanks, Sujit. And hey guys, Kishore here, enterprise architect with Kaizen Analytics. So I'm going to talk through the journey that we had with this financial institution. So Viral, next slide, please. Yeah. So, some of these challenges have already discussed, but I would like to reiterate on these challenges from the client perspective, which is one of them is ELK being self-managed service. Their team has to spend a considerable amount of time maintaining the cluster, doing patchworks or upgrades, or dealing with stability issues. So oftentimes they felt the disaster recovery capabilities are limited and time consuming on their ELK environments. So for instance, they have faced challenges when they were patching the Elasticsearch software. Some wrong configuration resulted in a 24-hour downtime for their stack. So it costed them a considerable amount of time and effort to resolve those issues. So that's one dimension of these challenges, and the other one is obviously high license costs. They are struggling to keep up and make the environment available for their log analytics platform. So additional scaling in order to support those data growing needs. So they have to spend a lot of resources in terms of scaling, and which is consequently giving them high license cost for doing that. Scaling. So the other aspect is like they have faced very slow support from the Elastic. As a result of that, like their outage windows are normally very long. So the most straightforward and simple solution for many customers who are struggling with these kind of challenges is to move to a fully managed service like Amazon OpenSearch service. So as Kaizen, like we see a promising path migrating to OpenSearch, a fully managed service offered by Amazon. Which can mitigate a bunch of challenges like these, right? So no additional cost, like we pay as we use, just like any other service that we see in AWS, right? And then obviously the support is great. And from OpenSearch perspective, like there are a lot of additional features that we have, like the additional security, like enabling encryption on your clusters, integrating any third-party authentication tools, like it supports SAML integration, LDAP. Viral, can you move to the next slide, please? So here in the slide, we show the current ELK environment that this client has, which supports a 2 terabyte per day ingestion throughput, and it constitutes of 120 plus applications. So saying that they are really thriving for more reliable environment which can support their data growth needs. So this is the prod environment that we planned, which can support 4.5 TB per day of ingestion, and given their data growth needs, that's 7.5 TB is what we are envisioning. So the bottom one is the non-prod environment that we set up, which supports 1 TB per day, as it is a non-prod, like the traffic is typically low. So moving to the next slide. So I'm going to talk through the migration approach that we have. So this is how we executed this project, and we call it as a migration framework. So this is a 5-stage approach where we capture all the critical aspects that we need to know for this migration. And I'll talk through a couple of phases in the next slides. Viral, can you next slide, please? So in this assessment phase, we listed the source and source types, whether it's applications or system logs or security logs, etc. And all of our questionnaires in this phase were tailored around how we can do the metadata enrichment and what the latency should be, and what should be the throughput, right? So for example, is there any processing necessary at this stage, or can it be deferred to the aggregator from a log collector perspective, or is there any additional metadata that we should add to any of the existing logs? Right? So these are the set of questions that we pose to our client to assess and understand about their data and logs. Next slide, Vidal. Yeah, so consideration in setting up the Amazon OpenSearch. So this is the interesting phase for me, where we had a lot of critical discussions on how we set up this OpenSearch cluster, right? Meaning, out of the cool features that it offers, what features can we leverage to reduce the operational costs at the same time without compromising the performance of the cluster, right? So topics like the read write patterns, right? So how can we use the ultra warm or cold storage feature depending upon their needs, right? So and defining those policies as per their high traffic times of the month, right? For example, when it is a mid month, so they expect a lot of traffic coming through their authentication platform, where they want like a very high availability of their logs at that point of time, right? So how can we set up that ultra warm or maybe cold storage features that will support this use case, right? And so other topic like cluster replications to achieve high availability of their log analytics systems, and auto tuning the cluster to be highly available. Right. So coming to the dashboards, like so we listed all their alerting criteria that they want to send, and defining the security and access control requirements. So given that, Viral, can you move to the next slide? So here in the slide, I'm going to talk through very high level epics of what this migration entails, right? Epics like converting the ILMs, like the index lifecycle management policies, to index state management, or tasks where we have moved the Kibana's saved objects to OpenSearch dashboards, and there are tasks related to recreating the roles and adjusting as per the new settings in the new environment, and additional considerations to explore new tools. For example, maybe can we use Fluentd instead of Logstash, or and translating any configuration to adjust to the new cluster. So overall, the DevOps, from the DevOps perspective, like changing any IAC, maybe Terraform or CloudFormation templates to reflect the new OpenSearch cluster. Right. So with all this, in the next slide, I'm gonna talk through the success criteria of this migration project. Here are the list of the technical success criteria. The client really needs to have all these KPIs to be solved through this migration, ranging from the integrations, right? So they wanted to integrate that third-party authentication platform, which is Okta, and enable the email and Big Pandas alerts. So data ingestion, alerting, visualizations, backup recovery, and observability, like the metric beat and heartbeat. So these are the list of success criteria that was set for us, and we achieved it from a technical standpoint. And in the next slide, so we have this functional, so from the operational or operational standpoint, so they want to have minimal learning curve. So the change management, whether we do upgrades or anything that we want to perform on this cluster, so they want it to be minimal. So given the managed service, like so that one is ticked off. And then the other critical thing is the migration timeline that we set for this project is to happen before their Elastic contract renewal. And overall, they wanted to be in a fully managed service where they can focus more on driving or maybe bringing a lot of business value instead of spending their energy and time in managing self-managing self-managing the environment. So with that, I'll go through this, I would say like a reference architecture, but these are the different components that are in play. So it's a very simple flow, having source where the data originates and gathered by the collectors and then in turn pushed to the aggregators where required transformations or data enrichment happens and pushed to the OpenSearch cluster. Here the magic happens, like where the indexing happens, and with all other cool configurations that we do with the auto tune or hot ultra warm or cold storage cross cluster replications. So it will be a very self-sufficient service that we can rely on. So in from this client perspective, or maybe this project, like so the yellow bordered things are what we have set up for this client, which really resolve all of the challenges through this project. So that being said, I'll hand it over to Sujit.
Thanks. Viral, can you go to the next slide? So for any customer that actually is wanting to migrate some of the messages that you've already heard from the team, what we realized was obviously working with the customer to have the application owners understand the data growth needs so that like partners like us can scale and configure the cluster accordingly is very important. And also working with the team, it's very important because you're migrating out from Elk to have a migration priority list, like how many, which is your critical or non-critical indexes that you want to migrate first versus put it on the later, just to, kind of put that project plan in perspective. Um, because working with a financial institution, we we would also recommend, like, if you are in that area or in even in other where security is a very important concern, then getting the architecture and security approval for your implementation and migration is something you need to understand and plan ahead. And then as you are working, these are requiring some of the open source technologies and also technologies like Logstash, working and iterating with Docker to remove any vulnerabilities is also something we would uh, want to work and remove it upfront from the stack. Uh, Next slide. I just want to show some of the timelines just because it was a financial institution. They wanted to, quickly migrate their non-prod into. So we followed a quick Kaizen um, agile methodologies to show them the value of the migration and then migrate all the indexes out from production. Can you go to the next slide?
I think that's pretty
Oh, that's
much
the last.
yeah. No worries.
Great,
Thank,
great.
thank, thank you, CJ. Thank you, team. Guys, this pretty much wraps up different perspective about how our customers, our partners are helping AWS customers at large to get the benefit out of Amazon OpenSearch managed offering. You heard that loud and clear from the different perspective, and that was the intent of this webinar. Not only you hear from us, but also from our partners as well as customers. How did they resolve that? So with that said, I'll open. We have a few more minutes to for question and answer. But as I mentioned to you in the opening part of the call, please ensure that you fill up the survey. This is completely anonymous, and also it will give you an opportunity. So, for example, if you like something about this webinar or you want to dive deep into a particular topic, there are some questions in the webinar in the survey. So feel free to put your details, and somebody from our services team or the specialist team would be coming back to you to address those questions. So while I keep this slide on, so that way you can take a QR code, or you can use this bit.ly link, which I'm showing on the bottom, we can open up the floor. So I'll ask our specialist SA team who is manning the chat to bring up any questions or any themes you saw you want to share with the wider audience. Maybe Chris, Kevin, Manish, or Bob, or Arun. Or we can open up the floor for question and answers too. Please ensure that you unmute yourself. You might be muted in asking questions. So please unmute yourself if you have any questions.
Hey, this is Kevin. I'll go ahead and chime in on a question presented by Nilesh here. The question was how many shards you had and how daily 20 terabyte data was distributed across these shards. Technically, when we look at how you present your data to either the Elasticsearch engine or the OpenSearch engine, you have the construct of an index. And the index itself, you want to try and distribute it as evenly as possible. Now, in the case of log analytics, which is normally where you see a 20 terabyte workload, daily ingest of 20 terabytes is going to be a large volume of shards. And when we look at the data nodes needed to support, an ingest, typically what we do is we look at anywhere from 45 to 50 gig shard sizes. So if you were to take 20 terabytes, multiply that times 1024 to get your gig, and then divide that final resulting number by 45 or 50, you will get a shard count. And this will basically define what your shard count is going to be for your primary shards. And normally, once you have that number, that's what you'll start off with for your daily ingest footprint for your sharding strategy. Now, keep in mind that primary shards typically you want to have a replica shard, so this doubles the size of the data. So if your raw data was 20 terabytes, you would have 40 terabytes of ingest. And when I see workloads this large, normally you're into a divisible number of let's say data nodes that can house those shards. Now, a little calculation the Amazon OpenSearch service team leverages is the concept of shard to CPU ratios. So let's just take a simple use case. I have a 5 shard primary distribution for an index with 1 replica. That's 10 total shards. If I were to deploy this, say, on an R5 large instance, which is one of our Intel-based offerings, what I'd try and do is deploy it across either 10 nodes of R5 large, which gives me a shard per node because there's technically 2 CPUs on the R5 large. Now, with 2 CPUs, we usually look at a shard to CPU ratio of 1 to 1.5. CPUs as just a rule of thumb to start with. Obviously, testing will give you your final number. But just to start with the size into our cluster, we want to make sure that the instance family can hold the storage for the shards and has enough CPUs to handle not only the ingest, but the query. So, it's probably a bigger discussion, Alesh, to address your use cases. But in summary, you want to ensure that you have even distribution of data across your nodes. If you have a very, very large cluster and a very, very large index, some cases it's better to decompose those that one large index, into smaller indexes so that you can manage the data a little bit more efficiently when it comes to sharding strategies. But in the end, your goal here is to either target shard size for all your indexes, which is between 45 and 50 gig shards for log analytics. For search use cases, typically you want to have anywhere from 25 to 30 gig shard sizes, and this depends on how your testing pans out. But you normally try and get even distribution so you don't have two things, data skew or shard skew. In the end, sizing is a complex activity. And while the Amazon OpenSearch Service team and specialists can give you a starting point, nothing replaces testing. And when you have to look at the end-to-end testing offering and the setting up of the cluster and figuring out how to do your sharding strategies, this is where partners can come in and help your teams with those estimates. But we do have some pretty good blogs. If you look into one of our principal specialists, John Handler with the Amazon OpenSearch Service team wrote, there's one called T-shirt Size Your Domain. And it does talk about a lot of fundamental things that I'm discussing here, and namely, how do you plan your sharding strategy? But I'll go ahead and pause for any other questions, but do keep in mind that the sizing exercise and your sharding strategy is everything when it comes to performance and cost.
Thank you, Kevin. And again, if somebody from our team can post that link, what Kevin was referring to, for the reference, that would be great. Yeah, we have 4 more minutes. Any more questions from the audience? This is time. You have the best lineup of search specialist team available to answer your questions.
Yeah, hi. My name is Vinod. I have a question regarding the previous architecture, because in the previous architecture we used aggregators, right, along with the data collectors. So, what's the purpose of using aggregators? So can't we just ingest the data, directly to the Elasticsearch in this case? Like, what benefits on the aggregators is giving to us?
Kevin, you want to take it?
Certainly. I'll go ahead and take that one. I was just trying to post a link in here for some of the sizing questions. So when we talk about aggregators, really what we're trying to do, and this will go back to our discussion around a 20 terabyte ingest workload. Normally, what you want to do is you want to use the bulk API on the Amazon OpenSearch service. And the one thing that you want to plan for, especially if you have larger clusters, now this is not typical for very, very small clusters. What I mean by small clusters, 2 data nodes, you might be pulling in a meg or a couple gig a day. But for those customers that do 20 plus terabytes a day, sometimes smaller, sometimes larger, you need to be able to decouple your ingest framework from the cluster. So for example, if you had a fleet of 10,000 containers and each one of them had a Fluent Bit collector that wrote directly to the Amazon OpenSearch service, you would overwhelm that cluster. You would have to plan for the spikes in traffic. You'd have to scale your cluster to a point it becomes cost ineffective. Now, what we do is we look at things like Kinesis Data Firehose, managed streaming for Kafka, Kinesis data streams, and there's other buffering patterns out there that basically allow you to collect all that data as it ingests. It will efficiently bulk the data and write it to the Amazon OpenSearch service. And if you happen to have spikes, let's say your traffic increases tenfold in 1 hour time period, you can't scale your cluster fast enough to accommodate that traffic. So you need an aggregator to efficiently buffer it and write it to the Amazon OpenSearch service, but you need a back pressure mechanism to ensure that you don't overrun your cluster and run into performance concerns. And so that's what we mean by aggregators. Now, if you look at Amazon Kinesis Data Firehose, it does have the ability to take that streaming data, use a transformation lambda, and write directly to the Amazon OpenSearch service. And it's really a hands-off offering for you, right? Nothing to configure but a window by which you would, like a 5-minute window, or every n number of gigabytes, go ahead and write to the service. And so this is all configurable, and it really gives you a managed offering for that ingest. But there are multiple, frameworks out there for it. But the main goal here is you want the buffer, and you want to be able to efficiently write the data to the Amazon OpenSearch service using the bulk APIs either on the Elasticsearch or the OpenSearch engines.
Great. Thank you. Thank you, Kevin, for that perspective. Any last questions before we wrap up,
So
guys?
one,
Yeah, go ahead, please.
this is Ashwin here. So the Kinesis Firehose that it writes to OpenSearch, does it internally use the OpenSearch bulk API with all the bulk
It
pressure,
does.
with all the big
Yep.
pressure and okay.
It does.
I mean,
Now,
inherently,
but
if we
go ahead.
sorry, go ahead. No, I mean, so this is Ashwin. Like we are from LabCorp basically. We use the bulk API directly, the open source bulk API with all those retry um, and back of exponential algorithm and stuff. So what you're saying is, I mean, we could just replace that with Kinesis Firehose, right? I mean,
Technically,
that's
you
what.
could. I always say that depending on the size of your workload, Kinesis Data Firehose works well up to a certain scale. And then after a certain point, you might consider other technologies, depending on how your test shows it. But you're correct. Amazon Kinesis Data Firehose does that bulking, does that packaging, has a back-off retry mechanisms, has an outlet vent so you can take your raw data and write it to S3 if you need it for historical reasons. And it has a lot of other nice features that means that you don't necessarily have to even self-manage your ingest framework, which is another interesting topic that we would love to do a webinar on. But you're correct. This might be a separate discussion we have with myself and maybe someone else on the specialist team to understand your use case specifically, because there are a lot of caveats and a lot of it depends. But when you get an expert such as a partner or someone from the Amazon OpenSearch specialist team, we can guide you down the best approach for your workload.
Great. Thank you, guys. We are 1 minute over, but I want to extend thanks to everybody who attended and especially our customers, LabCorp and our partner Kaizen Analytics for working together with AWS on this very informative webinar. And thank you all. And as I reiterated, guys, please ensure you fill up the survey so that way we can share the recording and also the deck for your later reference. Thank you all and have a nice day.
Thank you, everyone.
Thank you.
Appreciate it. Bye.